All right, everybody. Looks like our attendance, the people kind of filing in has kind of slowed down a little bit. So I think we can kind of get started here. All right. So for the moment, I am going to disable the chat just because I can't manage it while I talk, but we will be turning the chat on and off quite a bit during this one. So I'm just going to disable this. Okay. Let's get rolling, shall we? All right. Hi, everybody. Thanks for joining me today. I really appreciate you coming out. My name is Trevor, and I am a student and a teaching assistant here at Launch School. And today we are going to be talking about solving small problems in Ruby. Specifically, I know that we saw some JS people in here. I think you can stick around. All the syntax is going to be different, but as far as the logic of working through the problems, that works for any language. So feel free to stick around even if you're a JavaScript person. Anyways. Specifically, we'll be looking at the PEDAC problem solving method and how to debug your program when things don't work like you expect them to. This is the sixth and final webinar in a series of recurring Ruby webinars that we're hosting, which are primarily geared towards students enrolled in the prep portion of the Launch School curriculum. My fellow TA Claire hosted the first three. I hosted the last two, and I have the honor of hosting this final one. So if you were able to make it to some of those previous talks, you should have a really solid foundation from which to understand the information in today's presentation. That said, these have been designed as standalone workshops. So if you haven't seen the other talks, that's totally okay. I think even if you're brand new to Ruby, you're going to find this webinar useful. So I hope you stick around. And like I said, we will be dealing in Ruby syntax today, but if maybe you don't know Ruby, or maybe you're not super comfortable with any programming language quite yet, that's okay. I think the syntax and the actual coding part here is a little bit secondary compared to some of the broader concepts about problem solving and debugging. So let's take a look at the specific topics we're going to be talking about today. First, we're going to be talking about the PEDAC method, which is the primary problem solving method taught here at Launch School. Then we're actually going to be walking through the process of the PEDAC method to solve a coding problem together in real time. After that, we're going to be looking at some principles for successful debugging before hopping back into a code editor to work through debugging a program that I wrote together. And then finally, we'll have plenty of time at the end for a Q&A section. Needless to say, this is going to be a really interactive workshop, probably the most interactive workshop that we host, certainly the most interactive workshop that I host. And I am going to be totally following your lead on the problem solving and debugging portions. So with that in mind, I want everyone to know that this is a totally safe place to learn and experiment and make mistakes. I'm sure we have a lot of people with various backgrounds and experience levels here. So particularly on those interactive sections, don't feel bad if you don't know the answer to a question I ask, or you say something that's incorrect, or you don't immediately understand every change that I make to the code. That's all totally normal and expected. And if at any point you feel like you don't understand something, or you just want me to clarify something I said or I did, please just use that Q&A feature on your Zoom toolbar to let me know, and I'll get that cleared away kind of in real time. That said, I do request that during the interactive portion of the workshop, where I'm kind of prompting you to give me sort of ideas or answers, please just communicate with me via the chat function, which is separate from the Q&A, because that allows everyone to see what you've typed, and it makes sure that we're all just on the same page. However, again, if you need to ask a question, use that Q&A, because that lets me just keep track of which questions I've answered and which ones I still need to address. If you do ask a question in the chat, I'll try to address it, but there's a chance that it might get buried before I have a chance to. Additionally, on the point of questions here, if you have a question about something I just said, or you need me to clarify something I'm currently talking about, feel free to ask in real time, no problem. But if you have something kind of more general, or maybe even a comment, I just ask that you save that until the end of the Q&A, because that helps us stay on topic a little bit more during the presentation itself. And finally, I should probably let you all know that I do not know exactly how long this workshop is going to take, because it's so interactive, and it just depends on the participation that I get back from you. I've run it a few times now. Sometimes it goes over an hour, sometimes it's under. I expect it to be in the ballpark of about 60 minutes, but I'm totally fine if we end up going longer than that. And regardless of how long we do go, I'm going to stick around to answer everyone's questions at the end. So don't feel like you need to rush or worried that we're going to run out of time for you to ask your questions. I'm going to stick around. So if you stick around, I'll be here too. And then one final thing here is that you're all muted. I can't see you. I can't hear you. Neither can anybody else. Just me up here talking. So you don't need to have any paranoia about any of that type of stuff. Unless we have any questions, I think we can probably get started now. Cool. Okay. PEDAC method. What does that mean? Simply put, the PEDAC method is launch school's approach to solving programming problems. It's a method of deconstructing and fully understanding a problem and a potential solution before you jump into coding. As you probably guessed, PEDAC is an acronym with each letter representing one step in the process. So first, we need to understand the problem. This involves identifying the problem's inputs and desired outputs, and the implicit and explicit rules, or sort of like the boundaries of the problem. Next, you want to look at all the examples and test cases that are going to be provided to you and make sure that they all adhere to that understanding of the problem that you have. And additionally, you want to make sure that those test cases don't reveal any kind of edge cases or corner cases or gaps in that understanding. Then you want to identify any data structures you think you'll be working with in your solution. At this point in the curriculum, you'll probably be working with those more basic or more common data structures like arrays, hashes, both or neither. And that just depends on the particular problem that you're dealing with. And then after that, it's time to outline your algorithm, which is essentially just a step-by-step process for solving the problem written in plain English. While the answer to that data structure question is likely going to influence your algorithm shouldn't really reference any language-specific features, and it should generally be something that a person with like no knowledge of coding should be able to understand. And maybe more to the point, it's something that like a person who only knows a completely different language, coding language that is, could use to craft their own solution in their own language. So you're not going to refer to specific methods or specific feature or any features that are specific to your language. It's more kind of a general way of deconstructing that problem and arriving at a solution. And then finally, the last step here is that you code with intent by translating that algorithm into Ruby. So it's really just a translation process. You break it down into one language, probably English, and then you convert it to another language, Ruby. Okay, so at this point, you're probably asking yourself this question here on the screen. Why wouldn't I just start coding, And I think that's a fair question, and the answer really isn't immediately apparent until you have experience with both approaches. And it really does change depending on your experience level and the type of problem that you're trying to solve. For beginners, using a structured problem-solving approach is primarily a solution to something called the two-layer problem. This is a term that refers to the fact that people learning how to program actually need to develop two distinct skills. They need to learn how to solve problems in a logical step-by-step approach, like a computer. And then they also need to memorize the syntax and the technical details of the actual coding language that they're working with. And these two processes require two different types of thought processes. And trying to do them both at the same time is really frustrating and actually inhibits your ability to learn or get better at either one. However, using a structured problem-solving approach like PEDAC allows you to separate those two skills from one another. First, you work on understanding the problem fully and coming up with that logical solution, and then you can figure out how to translate that logic into code. As you gain more experience and comfort with a particular language, this becomes less of an issue, but the problems you'll be solving will be exponentially more complex. And with this added complexity, it's really important to have a solid mental model of the problem you're solving. And if not, if you don't do that, you're likely to end up with code that's kind of full of bugs or misses important edge cases. Utilizing a structured problem-solving approach like PEDAC actually ends up saving you a ton of time because you don't have to go back into your code and fix a bunch of stuff, which oftentimes is a lot more complicated than just writing it correctly in the first place. I will say from experience that I actually use the PEDAC process when I'm working on projects or trying to add features to something that I've already built. So at first, it might just seem like PEDAC is a cool tool for solving coding puzzles or like nailing interview questions. And it is, honestly, but it's also an approach that you can continue to utilize when you're building actual applications. So with that said, we're actually going to move over to a coding environment so we can walk through the PEDAC process and solve a problem together in real time. So that means I'm going to unmute our chat here for everybody. If I can figure out how to do so, which I can. Okay, cool. Okay, let's take a look at the problem that we're going to be solving here. So this is a real problem that is in the launch school curriculum. It's just one of like the Ruby, early on Ruby small problem sets. I picked it pretty much at random, so this is not perfectly tailored for PEDAC or anything like that. This is a real representation of how the problem solving method actually works in real time. So let's kind of absorb this in to the best of our ability now, and then we'll transfer into that coding environment and actually start working through the PEDAC process. Okay, so it's called daily double. Instructions are: write a method that takes a string argument and returns a new string that contains the value of the original string, with all consecutive duplicate characters collapsed into a single character. You may not use string squeeze or string squeeze with an exclamation point. And then there's a few examples or test cases down here. Okay, I'm just going to make my screen a little bit bigger. Cool. And then we're going to hop over here. I've actually just translated that here. So all of that should be the same. And let's go through PEDAC together, shall we? So I have my nice little PEDAC template. I do advise that, like, if you're entering an interview assessment or something like that, you just have your PEDAC, what did I call this thing? Structure, whatever, outline, ready to go. Saves you a little bit of time there. Okay, so problem. So like I said, on this step, what we're really trying to do is deconstruct the problem and to identify the inputs and outputs, as well as any implicit and explicit rules that are in the description of the problem. So let's start with that input and output. That tends to be the easiest part of this. Okay, input. Somebody share with me what you think the input to this method that we're going to be building is going to be. So what's going to go into the method? Okay, a string. Yeah. Nico, I think you're right. String object. Yeah, that's a little bit more specific, but string object, whatever, both work. Perfect. Nailed it. We're off to a great start. How about the output? What are we going to output? Also a string. Okay, and on this output one, I think it can be kind of useful to be a lot more specific than the input one, because we want to just identify, well, what is unique about this string, or what are the qualities of this string? Like, if we're just passing a string in and getting a string out, it doesn't really tell us anything about what the method does. So let's say we get a string out, a string that ... Who can fill that in for me? String with no duplicate consecutive letters. I like that. That's a really simple and kind of clear and concise way to describe what we want our method to do. With no duplicates. Cool. Input, output, done. So the other part here is we want to kind of understand the rules or the boundaries of this sort of problem here. And like I said, that's nice. It's nice to kind of separate this out into explicit and implicit rules, with explicit rules being things that are just stated in the problem or told to you by the interviewer, and implicit rules are a little bit more complex to see. Maybe they're not as apparent because you need to kind of look at the entire picture of the problem to identify those. So let's start with our explicit rules. What are some things that we know as a rule here, just based off of what it says? I can kick us off. I'll give us our first rule if you guys agree to give me our second rule. Well, we know that we can't use the squeeze or squeeze methods. It says right there, can't do it. Explicitly says it. So nice to just kind of reiterate that so we don't forget that or kind of brush over it. Anything else? Anybody? Must contain the value of the original string. I think that's good. Could we be a little bit more specific? Because it doesn't contain the exact value of that original string. because otherwise the method wouldn't do anything. It would just take a string and it would pass a different equivalent string out, right? Collapse into one character, yeah. With characters, let's just say collapsed. We know what that means right now. Okay. Anybody else? How about this explicitly? Are we getting a new string that's being passed out, or are we passing out the same string? Are we like modifying the string, or are we passing out a whole new string? New string, okay? Returns a new string. That's really important. We got anything else that kind of looks like just in the rules here that seems important? No, I don't think explicitly. Let's move on to some kind of like implicit rules, some things that we can kind of assume or kind of glean from maybe some of the test cases, or just sort of how we understand Ruby to work, right? I'll start us off here as well, because these can be a little bit tougher. I'm going to look at our test cases here. If we look at our test cases, we see that we have lowercase letters, we got some numbers, and that's it. So I can kind of assume that I don't need to deal with any other characters other than letters and numbers, right? I don't need to deal with punctuation. There's nothing funny if we have like a bunch of spaces in a row, like how do I handle that? I don't really need to deal with that. So we can just say, only need to consider duplicate letters and numbers. Anything else that we can kind of assume? Or the other thing that could be useful here is if you have a question, if you're getting an interview, you're being interviewed, this is a really good time to maybe identify things about the problem that aren't clear to you and ask the interviewer. So either one, any questions you would want to ask the interviewer giving you this question. Empty string returns an empty string. I think that's really good, right? Like we can see this case. Hey, well, what do I do if I don't actually, there aren't any duplicate letters, right? Well, we just return the equivalent of the input string. So that's really good. If no duplicate letters, return, we just say equivalent string. Anything else? I can think of like maybe one thing I'd want to ask. Personally, I would probably want to ask the interviewer, can I modify that input object? So if you're dealing with a mutable object, like a string or an array or a hash or a thing that can be mutated, it's a really good idea to find out if you can modify that, because we know we're returning a new string, but what if in the process of creating that string, we just, we mutate or we destroy that input string? Is that okay, or is it not? There's nothing in the problem that says that. There's no way for us to tell from the test cases. So it would be something we would ask, I think would be a good question. Can we mutate input? Okay, I think that's a pretty good idea. Again, with bigger, more complex problem descriptions or more test cases that we need to consider, this section can be a little bit longer and take a little bit more time. It's really important to fully understand the problem before you start working through any of them, any of the other steps. But I think we have a pretty good understanding as of now. So examples and test cases. What we want to do in this section is we want to take another look at these examples and test cases and just make sure they conform to our current understanding of the problem that we just laid out. So that's the first thing we want to do. And so we just do a quick check. We say that, it must have the characters collapsed. And if we look at this, yeah, the output looks like the characters are collapsed. We say we only need to consider letters and numbers. We check again, and yeah, those are the only characters in there. Okay, so that's pretty good. And then the other thing that you can do is you can pick one test case that looks maybe bigger or more interesting or a little bit more complicated. So to me, it's probably like this one, because we have this repeating pattern in there. And you can just walk through it manually to make sure there's nothing kind of tricky or strange in there. So we say, okay, we have 4 4s in a row. Okay, that gets compressed to 1. We have an A, B, and C. Those are all different. So A is different, B is different, C. Okay, so we got two C's here, and we got one over here. Okay, so that kind of conforms with our understanding. Again, that might seem like overkill, but when you're dealing with more complex problems or with larger sets of test cases, sometimes there's going to be a little tricky thing in there. So look out for them and just manually check that your understanding conforms to that. Okay. Data structures. Here's where we're going to talk about the data structures we're going to use. Anybody have any intuitions on that? Again, we kind of talked about, what types of data are we going to be dealing with? We're going to be dealing with arrays or hashes or something else. Possibly an array. I think, yeah, I think an array is possible. Oops. Let's just say array, and she said possibly, so we're just going to put a question mark there. Anything else? Anybody think we need a hash or anything like that? No? Okay. Oopsie. Let me say, maybe that's a question, maybe it's not. Okay, and then the algorithm section. Again, this is really the meat of this process here. I think it's probably the most time-consuming part and the part that you really want to get right before you start moving into code. It's a step-by-step description of how you would solve this problem. And again, you're not referring to any language-specific features or any particular methods that are available. So what might be our first step? Our first step here. We'll scroll back up to the problem. Anybody? First step in solving this? Give you guys maybe 25, 30 seconds to kind of come up with a first step. And if not, I can kind of give us our first one, I think. Iteration. Okay, give me more information there. You just said iteration. Identify unique characters. Okay, we got two answers here that I like. I don't know which is the first one. So let's say, okay, create a new string to build. I think that's a really good place to start, right? We can say create a new string to build because we know we're going to be returning a new string that has some letters in it. So we probably want to start off by creating that kind of empty string. Oh, Jasmine says even before that, we could just say, hey, well, define a method called crunch. Oops, what happened here? I can't copy and paste from the chat window, apparently. That's too bad. Define a method called crunch that has one parameter that we're going to call str. I think that's really good. Yeah, we're already seeing something take shape here. So we now have a method definition. It's going to be, the method is going to be called crunch. It's going to have one parameter. We're going to create a new string to build. And we have this idea about iteration. We have this idea about identify unique characters. And I think between these two, we have really the rest of the logic. We just need to build it out a little bit. So let's say more about this iteration piece. What are we iterating through? What are we doing on each iteration? Let's start with that first part. What are we iterating through? The characters in a string. Iterate through all characters. It's really tough having two places I can type. Okay. Iterate through all characters of input string. Oh, okay. And then Nicola says, And then on each iteration, we're looking for unique values. Okay, that's an interesting wrinkle you've added. Search for unique values. Okay, couple points here on this step, because I think we're on to something good, but we've really hit on one of the biggest stumbling blocks that people run into when they're writing their algorithm, is expressing things at sort of the right level of abstraction. Meaning, we could say very broad strokes, oh, the whole algorithm is you just look at the string and you get rid of any duplicate letters. Like that would be really high level. And then low level implementation on a much lower level of abstraction would be like, at each step you do this technical thing, and then that has a technical substep here and another one down here. And really the right level of abstraction for most problems is somewhere right in between those two. So we have this step here that says search for unique values. I don't think that's quite at the right level of abstraction. That's a really high level of high level idea, because if I just took that instruction alone and tried to write a line of code that translated it, I don't think I'd really be able to. So how could we be more specific and a little bit more granular about that step? Check if the current character in the... Ooh, two great options here, and I'll let you guys vote on which one you want to do. So option one is check if the current character in the iteration is the same as the next character, or push each character to a new string if it doesn't already exist in the string. Show of hands. And then Nicola says, actually, we're not looking for unique values. We're looking at not repeating values, which I think is a really good point. Okay, so of those two options, would we rather... Well, the person who gave option one now says, I want to do option two. So I think everybody wants to do option two, where we push each character to a new string if it doesn't exist in that string. Does everybody sort of agree with that? Give me some yeses or some no's, whatever. Yes. Okay, great. Yes. Okay. Push each character to new string if... Ooh, Charlotte, I was gonna wait until that became a bug in your code, but well done. You caught it in the algorithm phase. So Charlotte says, only if it doesn't match the previous character, not if it's not in the string at all, because again, what if there's an A at the beginning and then an A somewhere down the line? That's okay. So, okay, so push each character into a new string if it doesn't match the previous character in new string. Okay, I like this. I like this. Okay, I'm starting to picture here. Do we have any other steps that we need to take? Maybe at the end, maybe we want to return the new string. I think that's a really good thing. Return new string. Yeah, output. So Tyler, you hit on something really interesting. I had this thought when we were laying out our explicit rules. We did not specify, does this method output something, meaning print it to the screen, or does it just return it? And that's actually a really important distinction. So I think because you asked that question, it's time to go back into our rules and say, actually, we're going to check it. What do we do with it? Do we print it or do we return it? And it says returns. Return string, not output or print. Excellent. Excellent job, everybody. I think this is like pretty good. We might run into some things when we're coding it up and we can always go back into the algorithm, but we have a pretty good step-by-step process here. Okay, it's time to move into that final step, which is code with intent, which I'm warning you right now. I work in JavaScript a lot right now. So if my Ruby syntax is a little bit rusty, I apologize. I should be all right, but we'll see. Okay, So define a method called crunch that has one parameter string. We already did that. Check. Create a new string to build. You want to call it new? Maybe we'll call it result. New kind of in some languages is a reserved word, so that can be weird. So we're just going to say new string to build. We'll make it empty because it's not built yet. Fine. Iterate through all characters, spelled that wrong, characters of the input string. Okay. Depending on your level of familiarity with Ruby and the Ruby syntax, maybe this is one step, or maybe this is like two steps that should be divided out. Somebody tell me like what methods I'd use. I'm trying to code this up. Yeah, string.each car. In my head, I say char, but it's car, it's character. Stir.each car. And what that does is that creates our array, which makes sense. We said, oh, we'll deal with an array, but almost kind of implicitly here. Okay. And that's how we can do that. And if you didn't know that, you might have to break that into two steps and maybe split the character up into an array of characters and then iterate through. So again, maybe you'd go back into your algorithm and make it a little bit more specific. But since we know of the existence of this method, each car, that's totally fine. Geez, syntax. Okay. We got to do something. When I say we have a car. Okay, I think I'm getting it. Okay. Great. Said on each iteration, we're going to push each character to a new string if it doesn't match the previous character in new string. So somebody give me a line of code that would translate that idea into code. Anybody at all? Anybody at all for line 55? Well, we can kind of break it down into its sort of multiple steps there, because there's multiple steps there. So we could say result. Okay. We have a result, push. Charlotte, I'm digging it, car. So push each character to the new string. Our new string is called results. Okay. If, we need an if, it doesn't match the previous character in new string. So we need to see if car doesn't match, meaning it's like not equal to the previous character in the new string. That's maybe the trickiest part of this, is how do we get the previous character? And Charlotte's solution here is actually really good, where you just look at the last character, which in Ruby, fortunately, you can do very easily with the -1 in brackets. That's going to reference the last index of either an array or a string. Okay, that looks pretty good. And then we have return a new string. That's pretty good. Let's see, Ruby, that doesn't need to be explicit. We can just put it there. Okay, does everybody feel pretty good about this before we run our code? I'm not going to go until 3 people tell me they feel good about it. That's what's going to happen. We got a thumbs up. We got a yes. One more. I'm waiting for one more. Yes. Okay. Let's run. Looks good. Okay, everybody. Clear this out. What am I trying to run? We did it. That was actually really seamless. So first of all, congratulations, and thank you for all of your help. That was excellent. The second thing that I want to point out here is just how kind of relatively quick and simple it was to do the actual coding part of that exercise. Keep in mind that we're, I don't know, whatever, 15 people or however many people are here all over the world, just kind of like throwing out steps of code, you know. It's a pretty messy process, and it still went really, really smoothly because we laid that groundwork all the way up here. And ideally, that's how the process goes, because it is much more difficult to think your way through a problem as you're translating it into code, or even worse, get a whole solution that then doesn't work because it doesn't conform to some of the rules that you didn't pay attention to, and then try to identify where you went wrong and shoehorn it into the problem. Ideally, you work out all of the kinks when you're just dealing with the language that you're comfortable with, which is English, and then you can deal with that part of just line by line translating it to code. So well done, everybody. That was excellent. The other thing that I want to point out is that this is a really, really good example of an algorithm that's at the right level of abstraction, I think, for most of the people here. But again, we have like this line right here, which there's a lot going on there, because what are we doing? We're separating the character out into an array implicitly, and then iterating through each character. And so maybe we didn't know that that method existed. So we'd get to this part and we'd say, oh, how do I iterate through all the characters? I don't know how to iterate through the characters in a string, but I do know how to iterate through an array. So I'm actually going to change this into 2 substeps where I say, create array of all characters, and then iterate through. And then I can just move on as normal. And, you know, the code would look something like this. What would it look like? It would be like, I could use split to do that, split it on any space. So the code would end up looking a little bit different. The algorithm would end up looking a little bit different, but that's totally okay. Okay, everybody, that was awesome. Let's move on to talking about debugging a little bit here. Unless anybody has any questions about the PEDAC method before we get into the debugging type stuff. No? Cool. Okay. So like I said, that was great. And we got our program written without any issues or bugs. We took care of it before we got into the code, which is great. That's awesome. And it does happen sometimes, but honestly, just as often, you go through that PEDAC process, you get something coded up, and then you find out that it just doesn't work like you expected it to. And that's where the real hard work of software development, which is debugging, that's where that starts. Now for this section, I actually considered writing like a step-by-step process for debugging a program, but I realized that that's probably not the best approach, because debugging is a really idiosyncratic thing. The exact approach you take is going to depend on you and your personality, as well as the type of bug you have, the environment you're working in, and a bunch of other factors. So with that said, I think I was able to come up with some kind of like general guidelines for how to approach debugging your code that would work with pretty much anybody, regardless of their specific situation. Okay, so the first guideline is to develop the right temperament. This might seem like an odd place to start, but it's actually so important that it's the first thing mentioned in the lesson on debugging in the launch school curriculum. Essentially, what this means is working to manage your negative emotions and approaching the debugging process logically and with a sense of curiosity. Debugging is really at the heart of software development. So the fact that you have bugs in your code doesn't mean that you're a bad programmer. It just means that you are a programmer. It can be really frustrating when things don't work, but that's just sort of the name of the game when you're working on computer programs, especially when you're just starting out. You're going to have a lot of bugs, just how it is. So do your best to stay calm and logical, and also realize that making mistakes is how you learn, and try to remember that growth happens at that point of struggle that you're experiencing. So as much as possible, you want to think of bugs as an opportunity to learn something new, not something to get upset about. Now, all that said, I did use the phrase develop the right temperament and not just have the right temperament. That was really intentional, because I'm not saying that if you tend to get upset or flustered when your code doesn't work, that you're like not cut out to be a developer or anything like that. It just means that that's an area you can probably work on in order to be more effective at debugging, and honestly just enjoy the whole process a lot more as well. So assuming you're coming into the process with the right attitude, the first thing you probably want to do is compare the outcome of running the code in questions with what you expect the outcome to be. Sometimes that's relatively simple because you get an error message, and you know, you weren't trying to get an error message, It's pretty clear that the outcome of running your code isn't what you expected. However, other times your code produces something. It's just not what you wanted. And this is particularly relevant while solving isolated problems, like in an interview setting or like we just did together. Because oftentimes you'll be given a list of test cases that print true if your method has the correct return value, and false if it doesn't. And I'm always surprised when I'm conducting these interviews, when people run their code and get a bunch of falses, and then don't actually look at what their method is returning. They just go, oh, false, it wasn't what I wanted. And then they try to change things. It's not enough to know that your method isn't returning the right thing. You want to know what it is returning, so you have a chance of kind of working backwards and figuring out why you're getting that different value. This can be done by simply printing the return value to the screen using a REPL, which is a read, evaluate, and print loop, like IRB or PRI, which are tools you'll get exposed to in the curriculum if you haven't already. Or alternatively, you can move the code in question into like an isolated environment and do some tinkering or experimenting there. That can be helpful if you're dealing with like a whole bunch of code and you just have a method that's not working. Sometimes taking that out, putting it somewhere else, and seeing how it functions in an isolated environment can help you figure out what's going on. As an example of sort of this process, like imagine you have a method and it's named method 1. And then inside the definition of method 1, you call method 2, okay? Now imagine in your code, you see that method 1 isn't returning the value that you expected it to. The first step in figuring out what's going on is determining, is the issue within some logic in method 1, or is the issue with the logic in method 2? Because again, method 1 is calling method 2. So where's the problem occurring? If you've gotten that far and you still can't parse exactly what's going on, know that you have a lot of tools at your disposal. Sorry, should have put that up earlier. First, you can always use Google or your preferred search engine or a website like Stack Overflow to look for answers. Totally normal, totally okay. Additionally, you can check the Ruby documentation to make sure you're using a method correctly and you actually understand all of its behaviors, particularly early on. It's a lot of stuff to remember. So if your methods aren't doing what you expect and you're doing other method calls within them, check the documentation. Maybe there's an unexplained or an unexpected behavior that's just explained in the documentation. Alternatively, you can use IRB or PRI to see the return values of specific pieces of code in isolation. Again, it kind of comes down to isolating things out and identifying where the problem is. And then finally, be willing to step away if you need to, take a walk, grab a 5-minute, or just go work on something else. It's amazing how well this can work if you've spent an adequate amount of time loading the problem into your brain first. So probably not the first time, it didn't work, I'm gonna go get some coffee, that'll fix it. Probably not. But if you do spend the appropriate amount of time loading the problem into your brain and trying to scour for a solution, and you're starting to get frustrated, go for a walk, switch tasks, take a break, have some lunch, whatever it is. I can't explain why this works, but it is shocking how often it does. So with all that in mind, I actually, do I want to save that? Probably not, I think. Okay, so I actually have a problem that I wrote up, and here's what we're going to do on this section. So this is a whole complete program that has several bugs in it. And I structured this. I came up with this sort of like problem and all of the test cases, and then I did a PEDAC and I wrote my code. I know the PEDAC is good, but the problem is somewhere in the code, or the problems are somewhere in the code. So we're going to go through the problem. You're going to get to look at the PEDAC. And again, the errors aren't in the logic, the errors in the code. So I figured that would be a good way to show you kind of another example of like a PEDAC process, and then we can kind of work on debugging together. Okay, so let's just work through this one for the remainder of the time here. So here's the problem I came up with. Define a method that accepts a multi-word string as an argument and returns a version of that string with each word reversed. The method should maintain the position of commas between words and any punctuation on the end of the string. Odd. Okay, so let's look at those test cases. Howdy, howdy, howdy becomes howdy, 3 times backwards. Reverse word becomes reverse backwards, word backwards, but then notice the exclamation point, the punctuation stays at the end. Again, we have hello world here, hello backwards, comma, world backwards. So that comma stays there too. Okay, you get the idea with the test cases. So PEDAC, we know the input is a multi-word string. We know the output is a version of that string with each word reversed in place, maintaining position of punctuation. Okay, so I'm just kind of rephrasing what I'm looking for as an output. We know that the rules are explicitly commas and punctuation at the end of words should not move. It says that right in there. And the input string is going to contain more than one word. It says a multi-word string. So explicitly says it. Implicit, we can kind of look at these cases here and we can say, okay, well, letter case is maintained here. So capital H at the beginning, capital H at the end. Okay, apostrophes in the middle of words. So we saw this one as an apostrophe. That moves like any other character. So commas and exclamation points at the end of words stay, but apostrophes move. Okay. We know that we don't need to account for numbers because there aren't any numbers in any of our test cases, and me, the interviewer, says we don't have to. And then again, I asked myself, can I modify this string? And I said yes. So we can modify the string. Okay. Test cases and examples, we already sort of looked through those, and we just kind of confirmed that they all conform to those stated rules that we figured out in that first step. Data structures, I kind of thought an array would be a good thing to use here for the same reason as sort of that last problem, because I'm going to be dealing with breaking things up into smaller chunks. So I want to get my words broken up into chunks, and those will probably be contained in an array. Okay, here's the algorithm. Separate string into an array of words. Then iterate through the array of words, reversing each word. Okay. If the word now starts with punctuation, move it back to the end. Think about that. So if it was hello exclamation point, it's now exclamation point, O-L-L-E-H. I want to take that exclamation point, move to the end. Okay. And then to do that, I'm going to iterate through the array of the reverse words, checking to see if the first character is, oops, that should be punctuation. First character is punctuation. If so, remove the first character and add it to the end. Okay, so that was sort of how I broke that step down. Iterate through the array, look to see if the first character of any of the words is punctuation. And if so, you just take that character and you stick it on the end. Okay, and the way that I structured my actual approach to this problem, my actual solution here, is I broke each of these steps down into its own method. So I have this method, which all it does is it separates the strings into an array of words. I have this with if the word now starts with punctuation, move it back to the end, or no, I'm sorry, iterate through the array of words, reversing each word. That's what this one does or should do. And then if, we have a couple issues here. Nobody look. Okay, sorry about that. I think that's the solution. Yes, okay, cool. And then if word now starts with punctuation, move it back to the end. We have this guy right here. Great. And then I just apply those in order in sequence here. So I say, okay, separate them, reverse them, correct the punctuation. Very cool. Let's see what happens when we run it. Okay. We get an error. So error messages are actually good in the grand scheme of things. If you know you're going to get an error, you probably want an error message because they contain a lot of useful information. So we know that Ruby on line 63 in word reverse, we have an undefined local variable or method word R. Did you mean word reverse? Okay, so we know that the problem is on line 63. We know that it's got something to do with word reverse, and we know that there's an undefined local variable or method word array. That really helps us nail down what the problem is. So anybody looking at this code can kind of translate that into what explicitly is going on here. we start from the beginning, which is that we know the problem is on line 63, right? Because it says it right here, Ruby 63, word reverse, undefined local variable or method word array. So it's telling us explicitly that we don't have access to this. Word array hasn't been assigned a value. Okay. That's true, it hasn't. So would we want to do that? Where would we want to assign word array a value? Before string.split. Okay. Word array equals. Okay, let's go ahead and run our code again. We hit the same error. We hit the same error, even though we have a word array now. Fortunately, I'm working in an editor that gives me lots of little hints here. It says it's assigned but unused variable word array. And so here's my caveat here. Depending on where you are in the curriculum, we might be butting up against some of your technical knowledge. Hang in there. That's totally okay. This, like I said, this isn't really about the code. It's about sort of figuring out and deconstructing where that bug is occurring. And then we have a jump in technical knowledge that allows us to see what the bug is and why it's occurring. So we know that word array isn't available. Does anybody have any intuition about why that is? And if not, okay, since methods have self-contained scope, we can't access the variable initialized in the method separate words. Jasmine, excellent explanation of that. So we know that we can't access word array outside of the method if we define it in the method. So where do we want to define it? In word reverse method. But the problem with that, oh, we're in word reverse method. Yeah. You're right. Where? Because what we want is our word array to be an array of words, right, from the input string. So basically, we're trying to take those words and just separate them and put them in. And so we do that here. We separate them. After separate words string. So I think probably what we want to do here is we want to define word array. Word array is going to be the return value of separate words because all methods have a return value. So when you invoke a method, something gets spit out. Whether you use it or not, it does happen. And it just so happens that because of the definition of this method and how it's structured, the thing that's spit out or returned is that array of words that we want. So essentially what we have to do here is we need to capture it within that variable. You meant before, I know, Charlotte, totally fine. Okay, really good. So I think that should probably solve that problem. Let's run our code. Okay, good news, bad news. We no longer get that error, which means we did fix that bug. We're getting a bunch of falses, so we don't want that. And unfortunately, falses don't give us a lot to work with. So what do we probably want to do next to try to figure out what the problem is or where it's at? All we have right now is false. If we look back, there's a step on here that's very useful. Isolate the error, totally. But maybe before that even. Because right now, all we know is that this code, so basically what this code down here is doing, our test cases are saying, hey, the return value of your word reverse method should be this. And it's saying, is it this? It's comparing the return value with the desired return value. And it's saying, nope, it ain't that. It's returning something, but it ain't that. So what do we probably want to do as a next step? If we know it ain't that, what do we want to do? Okay, I have an idea. Check the return value, print the return value, output the actual return value, isolate the error, totally, yeah. So what we want to do is let's kind of just work through with one at a time here. That can be helpful. So otherwise you just get all of this output that's kind of hard to keep track of. And we can just say, okay, well, I don't want to print the comparison, true or false. I want to print the actual return value. So what is my method giving me? It's not giving me what I want. What is it giving me? An array full of nils. Well, criminy, that's not super helpful. Okay, but it's better than false. I know I have an array that has 3 things in it, which should be words, but instead they're nils. Okay, so here's where things get a little bit trickier is we have to move into the mode of isolating the error. And we talked about this a little bit during my section on debugging, where I have a method here that is calling 3 different methods. I don't know where the problem is happening. Is it happening in the first one, the second one, the third one, in between or something? I don't really know. So here's how I would probably start isolating this. Is I'm going to say, I'm just going to comment out. That's all that is doing. It's commenting out. So it means that code is no longer executed if you haven't experienced comments before. It's just like, it's the same thing as cutting the code out, basically. And I'm going to say, okay, so what is the return value of separate words? Let's start there. I'm isolating. Is that right? Okay. Yes, it is. That is right. Well, that's great news. All I wanted separate words to do was to give me the words in an array. Cool. Okay, so then what, oopsie. Then what about this one? So reverse words. Is that doing what I want it to? It is. So I'm getting, I'm right there in striking distance. Reverse word is doing what I want. So then my problem must be here, because I know that separate words is separating them out, returning what I want it to. Reverse words is separating them out, returning what I want it to. Or I'm sorry, it's reversing them, returning what I want. So then we know that our problem is somewhere in this method. Okay, so I know that this syntax gets a little bit hairy, so I'm going to walk us through it here. I actually left some comments to kind of explain what's happening here. This is what's called a regular expression. If you haven't seen those before, don't worry about it. But essentially, this line just says, if the reversed word starts with punctuation, move the punctuation to the end of the word. Okay. And I'm telling you right now that the logic right there on both of those lines makes sense. So we know that there's some error happening in this big chunk. I think we put in the wrong argument. Interesting idea, Nicola. So here's what we can do. We can just go ahead and comment all of this logic out. And we just want to say, well, are we getting the right argument in there? Are we getting the right thing? Let's find out. We can just, that'll print it. Yeah, if I just do word array, it's going to print that. I'll save it. So what am I getting in there? Oh, interesting, Nicola. So we're getting our howdies, when really what we want there is our reversed howdies. And we know that this is returning the right value because we already checked that, returns the right value. But then somehow that right value is not getting in to this method right here. Does anybody have an idea about why that might be occurring? It's in the wrong scope later. Interesting. Oh, I see what you're saying, because we have a parameter called word array, and we also have a variable local to that method that's called word array. That's interesting. Map should be map exclamation point. And why, Charlotte? Why should map be map exclamation point? So it mutates the word array. Okay, so again, we had this case here where we were returning the right value. But really what we wanted to do was take word array and mutate it so that that change persisted to down here. And again, this is all getting a little bit hairy and in the woods. If some of this isn't making sense, that's totally okay. Okay, so we've now made that change. So now we're going to check, well, what is word array now? All right, so now inside of our final method, we have the right thing. Great, let's uncomment it out. Let's see what we got. Still nils. Well, crud, that's no good. We still have nils. So here's what we might want to do in this case, because I feel like I've sort of hit a dead end here. And I go, I don't know why this isn't returning what I want. Now is a time where I might want to broaden my perspective a little bit. So I've been dealing with just this first one for a while, and it's been really useful, but I've basically butted up against the limit of the information I can extract from this first example. Maybe, some of these other examples are going to provide me with new information. So I can just run this again. Oh, false. Okay, I still want to see what I'm actually getting. I don't want to just see if it's working or not. I want to see, what am I returning? Okay, we got something interesting here. So that's all nils, but this one is exactly what I want it to be. So is that. 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 So what is different about the words that are doing what I want? All right. Maybe there should be an else in the conditional statement. I think that's a good intuition. We don't provide an option in our code if the statement for words doesn't contain punctuation. Okay. Else return word. And for anybody who's not super familiar with map or what's going on there, basically what happens is that this method goes through an array and it looks at all the values. And whatever is executed or returned by this block of code in here is what happens to that, or it's what that element is transformed into. So I had this block, this logic in here that said, well, if it starts with punctuation, turn it into something that ends with punctuation. So I had that logic, but I didn't have logic that said, well, what if it doesn't start with punctuation? So in all of those cases, this block was returning nil. It's like, well, you didn't tell me what to do there, nil. And that's where my nils are coming from. So that makes some sense. Okay, I got rid of my nils. Does that mean my code works? Let's find out. No, it doesn't. So why? It kind of looks about right here. So again, I can kind of go back and I can compare my expected result to my actual result. So here's my actual result I'm seeing. Here's my expected result. What's different? Anybody, the difference between, this and this. It's returning an array instead of a string. Okay, so how do I fix that? A couple different ways you do it. $2s. Let's see. Still false, and let's see why. I'll just comment out the first one here. Here, let me make this more readable for everybody. Oh, that's weird. So 2s ain't the method, apparently. I'll tell you what it is. So here's a little trick. Split has an evil twin, you could say, called join. And it looks exactly the same. It takes the same kind of arguments and everything, except what split does is it takes a sentence and or a string, and it breaks it down exactly where you tell it. What join does is it takes an array of things and it puts them into a string with the argument in between them. So what we can say is join. We split on all the spaces, which means we want to join on all the spaces. That looks true, 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 true. Is it all true? It's all true. Oof. Well done, everybody. So like I said, this is really tough, and it's really, really tough if some of the syntax is unfamiliar with you, or maybe some of the scoping rules or things like that, or mutation and your regular expressions and stuff. But my point is that even if some of that stuff was really foreign and really kind of strange, or maybe outside of your current technical ability, if we follow those sorts of steps that we talked about, where we're like, okay, well, I need to look at the outcome, the actual outcome versus the expected outcome, and then I want to try to isolate that. We didn't really use any outside tools, but that would help even more, especially bridging that gap for the technical ability. And luckily, we didn't have to step away. But really, it's those two things where you're like, okay, I want to compare what I'm actually getting with what I want to get. And then I want to isolate why that's occurring. And even if you don't know technically why, you could say, well, something with this line of code, this variable isn't getting where I want. Maybe you don't know why right now, and that's okay, because you can just figure that part out. You can just Google it, really. You can use your appropriate tool. Alternatively, it could be this kind of thing like, well, maybe you don't know how map works, but you were able to find out, oh, well, it works when I have punctuation, but not when I don't have punctuation. Maybe I need to say something about what happens if there isn't punctuation. You can just kind of intuitively get there. And that's where effective debugging actually happens, I think. And that's a little bit or a lot better of a process than what a lot of people revert to, which is just kind of hacking and slashing away your code, sticking stuff in there, seeing if it works, taking stuff out and seeing if it works. A lot of times that makes the problem a lot worse before it gets any better. Okay, everybody, thank you so much. I appreciate you sticking around. I know that we went a little bit over time. What I'm going to do right now is I'm going to post a feedback form. If you want to fill this one out, it'll take you less than 5 minutes. It gives me useful information. Charlotte, take care. Thank you. Tyler, take care. So I'm going to post that in the chat if you want to click on it. I'm also hanging out here. If anybody has any questions about this or, any other launch school or coding type stuff, can't answer all your questions, but I can answer some of them probably. Anybody questions, comments, concerns? No? Okay, everybody. Well, please fill out that form for me. I really appreciate it. I will stick around here like just long enough to finish this coffee in case anybody's typing out a long question. I don't want to duck out, but you don't need to stick around for that. You're welcome to everybody who's saying thank you. I appreciate it. Well, I guess that's it. Okay, take care, everybody.